What is today's date? Ashadh 7. Ashadh 7 means 21st of June 2024 means days are being shorter day by day. Shorter in that sense means your AC exam, isn't it? I'm not talking about the duration of days; it's quite longer one. But your study matter, very less time is left. Hardly 7 months left. Why? Shravan, Bhadra, Ashwin, Kartik, Moksha, Pos, March, Phagun, Chait. Oh, 9 months are there. So within 9 months, SE over. And today, students are going to present on the topic pressure, right? So what is the PowerPoint made? I don't know. So let's me welcome the presentator and Super Guru, right? Okay. Super Guru will come after some time and explain that first presentator, okay? Super Guru? Oh.
Namaskar and good afternoon to you all. As you all know, it's me, Luniva, standing in front of you to give presentation on the topic of pressure. Principle of hydraulic machine. Principle of hydraulic machine works under the principle of Pascal's law and magnifies the effort applied on it. To construct the hydraulic machine, two cylinders of different cross-sectional areas, say A1 and A2, are connected by connector T as shown in the figure. The apparatus is filled with liquid. There are two leak-proof pistons P1 and P2. If any force F1 is applied at the piston P1, the pressure exerted at any point on it is given by Pi equals to F P1 equals to F1 by A1. The pressure is transmitted equally in the point P2. Therefore, the force F2 is exerted on the piston P2 is given by P2 equals to F2 by A2. From the equation 1 and 2, F1 by A2 equals to F2 by A2 according to the Pascal's law. P equals to P2. P1 equals to P2. A1 A2 equals to, A2 by A1 equals to F2 by A1. If A2 is greater than A1, then F2 is greater than F2 is greater than F1. Thus, a small force can be used to exert a much larger force. Thus, F2 is greater than F1. Thus, the principle of hydraulic is coming up. The no liquid can be compressed. The pressure applied on the enclosed liquid is transmitted equally to each part. The ratio of cross-sectional area to a big cylinder A2 to that of the small cylinder A1 is equal to the ratio of the load overcome F2 to the force applied F1 in the machine, that is A2 by A1 equals to F2 by F1, or capital A by A equals to capital F by F. Some solved numerical problems. Example number 1 is to find out the X from the given diagram. In the given diagram, there is given cross-sectional area of the big cylinder A is 25 cm square, and cross-sectional area of the small cylinder A is 4 cm square. The load overcome by the big piston F is 500 Newton. Force applied in the small piston isn't given. So we have capital A by A equals to capital F by F. 25 by 4 equals to 500 by F. 25F equals to 20,000. F equals to 20,000 by 25 equals to 800 Newton. Thus, 800 Newton effort is applied on the small piston. Thank you.
Enough, super good.
Principle of hydraulic machine. The hydraulic machine works under the principle of Pascal's law, and it also magnifies the effort applied on it. Um, to construct a hydraulic machine, two cylinders of different cross-sectional areas, say A1 and A2, are connected by a connector T as shown in the figure. Here is shown the model of hydraulic machine. If any force F1 is applied at piston, Uh, the pressure exerted at any point on it is given by F1 by A1, and the pressure is transmitted equally to point P2. Therefore, the force F2 is exerted on piston P2, and according to Pascal's law, P1 equals to P2. So A2 by A1 equals to F2 by A1. And here is also given the principle of hydraulic machine. No liquid can be compressed. Pressure applied on an enclosed liquid is transmitted equally to each part. The ratio of cross-sectional area of big cylinder to that of the small cylinder is equal to the ratio of the load overcome to the force applied in the machine. That is A2 by A1 equals to F2 by F1, or uh, capital A by small a equals to capital F by small f. Here is given a numerical problem. In the figure, we need to find the value of x, and in the figure, it is given cross-sectional area of the big cylinder is 25 cm square. Cross-sectional area of the small cylinder is given 4 cm square. Load overcome by the big piston is 5000 Newton. Effort applied in the small piston, we have to find the effort applied in the small piston. We have capital A by small a equals to capital F by small f, and by solving this, thus 800 Newton effort is applied on the small piston. Thank you.
Thank you. It's okay. But what is the difference between presentator and super guru? Same thing. Presentator also come in red. Super guru also present in red. What is this? So this is not the system, no. They have to just come and explain. Only reading same thing means how they become super guru. So this practice is not sufficient. Remember, this is the diagram of what is this? Hydraulic machine. Why is it called hydraulic machine? Hydro means water. What is used here? Water. The hydraulic water machine contains three cylinders. One smaller one, another bigger one. They are connected by another pipe. Here we can take another also like this. If you take a small pipe like this, and liquid can go from here. But here, this is cylinder with small cross section area. This is the cylinder with big cross section area. So cylinder of area of small cross section area is written as A1. Area of big cross section area is written as A2. When we apply some force here, what is it? F1. When you apply when that load is overcome, what is it? It's called F2. A1 area, F1 force. A2 area, A2 sorry, F2 force. Area and force. But why A1 and F1 and A2 and F2? Because there are two forces, right? Two areas, two forces. And what is the formula to calculate pressure? P1 equals to F1 by A1 and P2 equals to F2 by A2. Pressure exerted on this side is F1 by A1. Pressure exerted on this side is how much? F2 by A2. Pascal's law, what does Pascal's law say? Liquids transmit pressure equally in all direction. What is there? Liquids transmit pressure equally in all direction. If so, P1 equals to how much? Sorry, I said P1 equals to P1 equals to P1 equals to how much? P2. Both pressures are equal. P1 is how much? F1 by A1. P2 F2 by A2. And if we write here A2 is up, A2 goes up by A1 equals to F1 comes here, F2 by F1. This is the formula at first we got here. What is that formula? F1 by A1 equals to F2 by A2. But this A2 goes here, A2 by A1. Then this F1 comes here or not? F2 by F1. Tell me, A1 is bigger or A2 is bigger? If so, A2 is bigger than A1. If so, F2 also will be bigger than F1. So, by the application of less effort, we can overcome more load. Okay? Suppose if we apply here 40 Newton effort, how much load can be lifted? 40 Newton or more than 40 Newton? More than 40 Newton. Maybe let's say 80 Newton or 200 Newton, something like that. Yesterday only we discussed about application of Pascal's law. Where is Pascal's law used? Hydraulic brakes, hydraulic press, and hydraulic cranes, hydraulic garage lift, etc. Right? Because here we have one thing you have to remember. Principle of hydraulic machine is given here. What is that? No liquid can be compressed. We cannot compress the liquid. Second one, pressure applied on an enclosed liquid is transmitted equally into its part. And what is third one? Ratio of cross-sectional area of big cylinder to that of the small cylinder is equal to the ratio of load overcome to the force applied. It means, what does it say? A2 by A1 is equal to how much? F2 by F1. A2 by A1. Suppose, one thing remember, how many times more load can be lifted? For that, if you find the ratio of this, we can find out. Suppose A2 is 400 meters square. A2 is how much? 400 meters square. And A1 is 20 meters square or square meter. What is the ratio? What is the ratio of A2 by A1?
2:1.
How much does it come?
2:1.
20. 400 divided by 20 is how much? 20 or not? Right? So, we can lift 20 times heavier load by the application of this machine. So, you must find out. And one numerical problem was solved. The numerical problem says here, for big cylinder, area is capital A. Or you can write A2 also, okay? And small cylinder, area is small a. Load overcome by the big piston, capital F, is just like dominant character, recessive character, big and small. And effort applied in a small piston, F equals to what? Pascal's law, what does it say? What does Pascal's law state? It says P1 equals to
M.
P2.
Yes.
Pressure of exerted on small cylinder is
F1.
small f by A, small a, right? And pressure exerted on large piston is capital F by capital A. Now put the value. So P1 is means small f is how much?
Small f.
We have to calculate. Small a,
Small is 4.
4 cm square is given, right? Is it given 4 cm square or not? But cm square must be converted into meter square. How to convert?
So divide
4
by
divided by 100 multiplied by 100 m square. To convert centimeter into meter, you have to divide by 100. But cm square into m square means you have to divide up by how many times? 2 times. Then it comes 4 times 10 to the power minus 4 m square. Will you check in your calculator? Will you check in your calculator? 4 divided by, if you write 100 divided by 100 multiplied by 100, it comes 4 only. But you must get 4 multiplied by 10 to the power minus 4. How much you get?
4 into 10 to the power minus 4.
Does it come? Please do accordingly. Many children they do mistake while dividing. 4. So if so, how to divide this one? 4 and divide sign bracket 100 multiply 100, then your answer will come. Then you put the value by 4 multiplied 10 to the power minus 4 equals to F is 5000 by here 25. Now you can do here F equals to 5000 multiplied by 4 times 10 to the power minus 4 divided by 25. Okay, student, will you try how much does it come? Where's your calculator? Divide, everyone. Next, whose turn? Who made the slide? Or Nilisa? Pujana slide is here. Pujana Sreshta, chapter 8, I think, right? With that, Luniva. Now it's a turn of Nilisa, but Nilisa is absent, right? So, whom to call? Simres? Simres, he doesn't want to come. Who wants to come then? No? Okay, now let's do. In her absence, so I will just continue this one. The devices which are based on Pascal's law are hydraulic brake, hydraulic garage lift, hydraulic press, hydraulic crane, etc. Right? What is given here first? Hydraulic brake. What is here? Especially, this is a braking system used for 4-wheelers, for car, taxi, taxi also kind of car, right? Trucks, jeep, or lorries, etc. What is given here? Is there given the diagram? First, let's read what is mentioned here. A hydraulic brake consists of a tube T containing brake oil. Yeah. What should be used there? Brake oil. Especially they use a kind of thick oil. Okay, brake oil is much more thicker than water. Water has less density, but the brake oil has more density, so that it can transmit the pressure easily. One end of the tube is connected to the master cylinder, C, fitted with a piston. There is piston connected to the brake pedal. Brake pedal. So where person's right leg can touch it, right? So I think you haven't gone for learning this driving. And when you go for driving, then at first they say ABC. What do they say? ABC. You must learn ABC. Then what is A? Accelerator. B. Brakes. C. Clutch. See? These are very, very important. All they are near to your right leg. Understood or not? In case of motorbike, accelerator in right hand,
Clause in left.
Brake also in right hand, clutch in left hand. But
Leg. Leg in left.
yeah, backside leg is yeah, that's right. The other end of the tube is connected to a slave cylinder to a CT, which has two pistons connected to the brake shoes. The cylinder, how is it? The cylinder CT has a larger diameter than C. Both cylinders also contain brake oil. So I will just show you in the book how this works. What is given a working procedure? Please read it once again, everybody. Yeah, please read. Exerts. Okay, then exerts pressure. Continue. And the piston and the vehicle. What happens? It stops, right? Oh, what a diagram is given here also. She has made. You can see. This is brake pedal. Can you see a brake pedal? What is kept here? Oil. Brake oil is kept. Small tube is here. And slave cylinder. This cylinder is called slave cylinder. This cylinder is quite bigger one. When someone uses pushes this pedal, and here is piston or not? The piston pushes the liquid inside, inner side. Then the liquid goes here from this side and pushes this brake piston both sides, and the wheel is stopped. Braking system is like that. And when it releases it, again the piston comes out, and here is less liquid, and no braking system is there. Very simple. Press this one, piston moves inward, liquid goes here from this side, it is here and pushes this brake piston outside, and it it stops the rim of the wheel to move. When it lifts it, again liquid returns back to the same position, and braking system does not function. Hey. Now next one, what is here? Hydraulic jack. Hydraulic jack. Who uses hydraulic jack? That especially khalassis. Do they use hydraulic jack or not? To lift the vehicle while changing those punctured wheels. Have you noticed? Yes, hydraulic one. What is given there? Please read, everybody.
I will take for wheelers to lift and while changing weight their wheels and different diameters which must be indicated with the
What is reading like Baji? Here also, what can be done? By the application of less effort, heavy load can be lifted. See here. So this thing, you can see this device. What can you see? What can you see? You cannot see that device. This device, I said, and gone somewhere else. Here is pump handle. What is applied in this pump handle? Yeah. Force is applied here, right? And this is lifting piston. It can go up, it can come down. How can it go up? Because of this liquid system. Can you see a liquid system? Yes or no? When it presses, liquid goes up and slowly this piston goes up. When it lifts it, it doesn't go up. So here also is transmission of pressure equally in all directions. So always remember, the piston, this is the piston, where we apply force should be smaller one, and the piston on which load is connected, that should be of bigger one. It means its area area of small piston must be much more than that of bigger piston, right? It must be much, area of small piston very less, area of big piston must be more, too much more. Suppose if their ratio is 200, suppose area of large piston and small piston is 200, then we can lift 200 times heavy load also. Like if you apply here 50 Newton force, then we can lift here 50, 20, 200, how much? How much? 10,000, isn't it? 50 multiplied by 200. How much does it come? 5 to the 10. 10,000 Newton can be lifted. That's why the piston in which we exert pressure or apply force should be smaller one. The piston on which load is connected should be much more bigger one. What is next one? Hydraulic press. What are we discussing? We are discussing the devices which are based on Pascal's law. What does Pascal's law say? Liquid transmits pressure equally in all directions. Very simple. What do you say? Liquid transmits pressure equally in all directions. Right? So there must be minimum 3 cylinders. How many? Small cylinder where we apply force, big cylinder where load is connected, and then another connecting pipe also should be there, right? So that liquid can go. Hydraulic press. What is the purpose of using hydraulic press? What does it do? It helps to compress. See, cotton is very, very light, isn't it? But cotton can be compressed and changed into very smaller piece, smaller size, right? Plywood also. Why not? So, here's the device. What is this? Hydraulic press. So, this is fully automatic one. What is this? Automatic. So, here are the pistons. This piston, can you see here or not? This piston is responsible for pressing the things. It can move down and up. And excuse me, smaller pistons are connected here. Can you see smaller pistons? Yeah. These pistons, in this piston we apply less force, and by the help of that it is transmitted and large amount of force presses the things. Next thing is here. What is this? Up thrust. What is that? Up thrust. First read what is given there. So you might have noticed, suppose there is a beaker with some liquid, right? What is here? Liquid. And take one small bowl. What do you take? Bowl. And the bowl lies inside the water. When we hold that ball inside water, it feels a little bit lighter, right? And when we lift a little bit up or out of water, then does it feel lighter or heavier? Heavier. We have noticed like that. And have you ever pulled water from the well?
Yes.
When the bucket is inside the well, is it heavy or lighter? Quite lighter. But when it comes out, when you go for swimming, you can do diving in water also, right? When you are inside water, what do you feel? You feel quite lighter or not? You think something is pushing you upward, right? But when you come out, it's not like that. That means that force of liquid which pushes anything upward, that is called up thrust. What is it called? Up thrust. So you might have noticed. Take one bowl or bucket. What do you feel here? water. And put here one ball. Does the ball go inside? No. When you press that ball, it may go up to certain time down. Again, does it come up or not? Why does it come up?
Here.
Because of the upward pushing force of liquid. So if any object is kept inside the liquid pushes that upward, the object upward with some force. That upward pushing force is called upthrust. Upward pushing force is called upthrust. You know, earlier we discussed about free fall and air resistance. Air resistance means, does the air push the things upward or not? That is also a kind of upthrust. What is it? Upthrust. Is here given any definition? Good. What is given here? Please read it here. Hello, class 10. When a body is partially or wholly immersed in a fluid, fluid means the thing which can flow. Two things can flow. Eh? How many things can flow? What are they? One is liquid, another is gas. Gas also can flow. Gas can flow in any direction, but liquids can flow from higher level to lower level. So, wholly immersed in a fluid, the resultant thrust or force acted on it by the fluid is called upthrust or buoyant force. Remember these things. What is it called? Upthrust or buoyant force. And because of upthrust, the body becomes lighter inside liquid. When the exerted buoyant force, oh, the floating is different. Okay. Suppose here is one stone. Stone weighs 50 Newton in air. In air, how much does it weigh? 50 Newton. When we keep this same liquid, same stone in water, what will be this weight? It will be how much? Let's say 14 Newton, 13 Newton, 20 Newton. Why does it decrease? Because of upthrust. Here we have to make concept clear that if anything is kept inside the liquid or fluid, it pushes that liquid with some force. What is that force called? Upthrust or buoyant force. What do you call it? Buoyant force. And it is said, if that upward pushing force is equal to weight of the body, then the body floats. The body completely floats. Here is given an object is kept inside the liquid. See, it is pressed downward also, sideways also, this and that. So, these two forces, left side force and right side force will be equal and opposite. But upward force will be more than downward force. Upward force is more than downward force. So, it will be like this here. U means F2 minus, U means how much? F2 minus F1. It means how much force is applied from downward, that will be more than upward one, and that difference force is called upthrust. Now finally let's remember, if any object is kept inside liquid, two type of forces act on it. Suppose this is liquid, if you keep any object inside liquid, how many type of forces are act on it? Two. One force acts downward, that is called gravity. Because of gravity, it is pulled downward. And another force acts upward. What is it called? Upthrust. Sometimes question can be asked. Name the two type of forces acting on a body when it is placed in liquid. So what are they? Gravity and upthrust. Okay. So what is here? Thank you. Up to this much we have presented. Nilisa Joli's presentation. Right. Now whose turn next day? Susan, Srizal, and okay. I think tomorrow you may be Sunday means tomorrow means Sunday. We'll complete this one. And children, tomorrow is Saturday. Did I give you already some project work or not? So please do that one. Right now, please read up to here. Then note making time. Is that clear? So when we complete our lesson, then again we have to revise once again. Okay, please. Start.